Okay, here again Nabil Mohammed Abdul Momin. This is a solution on the derivative of voltage of a circuit with respect to t. So first of all, this is a circuit. We have your diode here, you have your resistor, we have our 3 diodes, about 1 2 3 4 5 diodes, and we have our capacitors, we have our inductor. Sorry, the inductor should be kept here, and then that is it. First of all, what we need to do is we need to know that V is equal to IR, and we need to know to find I. We need to know I is equal to V over R, and if you want to find your R, we can say V is equal to IR. If you want to find your R, you divide here by I, divide here by I, it gives you R is equal to V over I, sorry. First of all, we need to know a resistor represents R, your inductor is L, and your capacitor is C. And we need to know again, in the circuit, we need to find your IR, we need to find the I respect to R, we need to find your current respect to your inductor, we need to find your current respect to your capacitor. So what we do is, your current respect to your resistor will be equal to, we all know current is equal to V over R, that is the voltage over the resistor. So to find your current respect to resistor, that's equal to your voltage over resistor generally. Yeah, so we know that. And then when we move to your inductor, we can say 7 here, or let's say, okay, okay, this is somehow close. Okay, 7 here over L over this L, which is integrated to y t dt, which we have our high limit to be t and our low limit to be minus infinity. And then we go here to the current respect to your capacitor, which is C dy dt. So we all know that in Kirchhoff's circuit law, the sum of the currents entering or leaving the node is equal to 0. So we can say IR from here, and IL, which is your inductor, and your IC is equal to 0. So we just input the functions as according to their correspondence here, and we equate it to 0. So we multiply each fraction by 1 over c, so we can have some cancellations out. And here it is. So we can say 1 over c times yt minus vt all over r plus 7 over l integration sine higher limits gives you t, lower limits gives you minus integration minus infinity yt dt plus c dy dt equal to 0, which we are multiplying by 1 over c. You multiply by 1 over c. So for here you can see this c cancels this c, leaving y dy over dt alone. And now for this c multiplies this r, which gives you rc here, and this l multiplies this c, which gives you ld here, and then you are good to go. So when we are done with all these, this is where confusion comes in place. This part, we have to differentiate each of the fractions we have. Here is 7rc. This is dy dt all over rc. If we differentiate it, we are gonna get 7dr, 7 over r times c times dy dt plus 7 over l. When we integrate this, we are getting a normal function, 7 over lc times y t plus the square y. When we take the second differentiation of this, we are gonna get the 2y over this t square, which would be equal to vt over rc. And then when you do your maths well, you're gonna get 7 over dc, 7 all over rc times dv dt, which we've gotten 7 over rc respects to dv over dt. So that is all about this question. And then we go to the next question, which is all about simultaneous shifting and scaling of a graph. Okay, for this, let's go this way. First of all, the graph is one. The graph is this. Okay. Like this, and we move it from the normal scale to an amplitude scaling. An amplitude scaling, which means it should have a high amplitude. For example, we can take an amplitude of 4. So to take an amplitude of 4, we're indirectly making the apex up to 4, which is like this up to 4. Let's assume this is our 4. Then we take it downwards, which gives you -1, 1. And from amplitude scaling, we take it to the time shifting. The time shifting, which is telling us the time the graph, or the time the graph should move and how it should move. For example, let's move to the time shifting. The time shifting, let's say it's 3g t minus 1. The t here is positive, so we draw it like this. But due to this -1, we take it from the middle here upwards to 1, because if you say t minus 1 equal to 0, t will give you 1. So we take it from 0 to 1. So we are indirectly saying t equal to 0 and t equal to 1. So we start from 0 to 1, which is giving you the same amplitude of 4. And then we move to time scaling and reversing, which means we are just scaling the time and then we are reversing it, which means we are just taking the opposite of the amplitude scale. That's all. So as you can see, the amplitude scale for here was this. This was a amplitude scaling. Good. So right now we are looking for the time scaling and reversing. We've gotten the amplitude scale, we've gotten the time scale and reversing, we've gotten the time shifting. So we are now talking about the time reversing. The time reversing is just opposites of the amplitude scale and opposites of the time shifting. which the time shifting starts from 0 to 1, and which has an amplitude of 4, and then just the opposite of the time shifting. That is all about this question, changing it from the amplitude scaling to the time shifting, and then to the time reversing. That's all. And then we move to the last question, which says draw xt equal to 0.8 sine t sine pi t between t equal to -2 and t equal to 2. So the solution, first of all, we need to find our amplitude, which the general formula is, let me make the variable be xt equal to the amplitude sine pi t plus theta, which we can say here theta would be 0 because in the formula, in the question given, we are not given theta, so we assume theta is 0. But we can also say period is equal to 1 over frequency, and then you know frequency here is equal to pi t all over twice of pi t. So if this cancel this, it will give you 1 over 2. So we can say the frequency here is 1 over 2, and then we know period is equal to 1 over frequency, so you have 1 over 2, which gives you 2 seconds. So we have your period of 2 seconds. Good. And then we have an amplitude of 0.8. So we now scale the graph. The graph is being scaled from -2 to a high amplitude of 0.8, and then bringing it down to -1, taking it in between 0 and on a high amplitude again of 0.8, bringing it down again to 1 and taking it through a high amplitude of -0.8. So and it goes that way so the end here is 2 because it says, the question says the time should be between -2 to 2. And that's all about this question. Not really difficult. Okay, you can send me your questions and then your comments below on this. Thank you very much for listening. Have a nice day. Bye.